Thank you so much for finding the time for us. It's really nice talking to you. Just as a start, as an introduction, can you tell me a little bit about yourself, about what you do in tech and how you got started in the beautiful world of tech?
Yeah, the beautiful world of tech. I have been in it for a very long time, since I know myself, to be honest. The first time I wrote a piece of code, I guess it was when I was 12 or something. It started after the high school. I started my own company. It took it around 8 years. Did have a product and, did do a lot of the, services business as well. Then another 8 years, 4 + 4, 2 separate SaaS businesses, totally cloud native. And after that, had a year of consultancy. And then for the last 2 years, I'm working at Microsoft as the app innovation tech lead for Middle East and Africa. So that's pretty much my background. I'm coming from a developer background, engineer background. Half of my career, more than half at this point, I suppose, was about backend. 25% of it was client apps.
Okay, so you are overseeing Azure innovation in the Middle East and Africa. Tell me something about what do you believe the Azure in itself and cloud computing as a concept has brought to these regions?
It's huge. I mean, just to be specific, the workloads that I oversee is application development part of Azure. Obviously, Azure is huge if you look at it. My focus area is, companies that are building applications that are going to run in the cloud or migrating their applications to the cloud, and specifically the platform as a service offerings, right? Not the infrastructure as a service stuff. And obviously, the value is huge. It's not specific to Middle East. It's globally, right? Moving to the cloud helps with the efficiency of the platform, lowers your costs. In terms of not the infrastructure cost, just the infrastructure cost, but your development costs as well, the people costs that you have. And it increases your productivity in terms of an engineering organization, or partially. Not every organization is a fully engineering organization, but they do have engineering teams or partners that they work with that they're building software, right? So you increase the efficiency of the software itself by lowering the cost, by improving the performance or the footprint of the application, or you kind of go back and focus on the development processes, and you bring in the agile concepts, and you support that with the underlying technology as well. And pretty much all of that comes to the fact that it's all about first increasing efficiency, and second, through the increase in efficiency, being able to do stuff, enable capabilities in organizations that organizations would not be able to get to just due to the resource constraints that they had. So through the increase in efficiency, you were able to release additional resources in the organization that can go in and kind of enable these additional capabilities and bring business value.
So as far as I know, you've been involved in quite a number of SaaS startups and cloud products. What are some of the challenges you've encountered while developing and launching them? Could you share some of that experience with us?
So there's a bunch of challenges when you're building products, right? But the biggest one that I see repeating over and over throughout this experience of a particular, engineering team or an organization building a SaaS solution is the fact that when you get into it the first time, right, you tend to, and this tendency is not specific to the cloud, but it surfaces in a different way, which is you end up over-engineering stuff, right? But this time, the over-engineering surfaces itself in a different way. And let me explain. So when you go to any cloud vendor out there, what you're going to see is that they have a service for everything, right? They have a fix for every problem that you have. And then when you start designing your own product, your own architecture, and you are adding, features and stuff during the time, right? You're going through 1, 3, or 4 years of development cycle, iteratively improving your product. So, and when you do that, every time you encounter a particular need, that usually maybe in the past days, you would sit down with your engineering team and decide how to build it. But now that you got all of these offerings from out there, the first reaction is, what's available? Because we don't want to create the world from scratch. We want to reuse as much as possible, because that's kind of the starting point of this whole cloud kind of was. So you go out there and you look at these services, and 90% of the time there is a service that fulfills your needs. And then you go in there and you get that service, you incorporate that into your product. But here's the deal. In 4 to 5 years, where you end up is you have like 50 different services from a cloud vendor, or maybe sometimes multiple cloud vendors, incorporated into your product. So your product relies on 50, 60 different services, managed services in this case, to function properly so that your product can create value for your customers. Is that wrong? That's the question. It might be or might not. The primary question here is, was that intentional? Did we intentionally come to this point where we have 60 different dependent services and, we have a SLA to hit? And if you get a composite SLA of all of these services that we have, it's really tough to hit our own SLA. So was that intentional, or did we end up saving the day by simply finding solutions that were fixing our problems for the day? Or could we have everything simplified? It has to be a highly intentional process. Every time you incorporate a particular service, even though it might look beautiful, it fixes your problems for the day, you should always think like, every time I'm adding a piece into my architecture, the fact that I'm going to be carrying it forward for a couple of years, or do I have a timeline? Do I have a plan what to do with it in the future? Like, that intentionality is critical. I have had this experience firsthand because I've gone through multiple startup cycles and built multiple products. At one point, specifically with the third product that we were building, the second cloud native product, the rule of thumb was that, hey, every time we bring in something, we have to be crazy intentional. And our goal isn't to bring in additional services. Our goal is to keep things as simple as possible. And because that availability of easy turnkey solutions out there sometimes makes it easy for you as a decision maker and product manager to just say yes to feature requests that you wouldn't otherwise say yes. Right? Just the fact that you have an easy solution out there makes you feel like, okay, yeah, we can do it. But what is the long-term impact of having so many underlying services from so many vendors? That was one interesting challenge that I, experienced during the years. I learned a lesson, to be honest.
What would you say are the criteria that you use to decide whether something should be a dependency or sort of an in-house development, or discarded as a feature completely?
It's not really a dependency or an in-house question. It's more of a, should we do this by depending on someone, or shouldn't we do it at all? Because we cannot afford doing it in-house anyways. Should we take a dependency and enable this for our customers? Because when you look at a particular, let's go with a particular feature, like feature X. What you do is you kind of, try to estimate the cost of the implementation cost of feature X and try to understand what would be the return on investment in terms of, how much value you're creating to your customers and how much return you're going to get from it. But that variable that holds the cost of the implementation of that feature is drastically different if you have built it in-house versus you have implemented a third-party solution into your product, right? So if you calculate the return on investment from the cost basis of using a third party, the initial cost is much lower. If you have calculated the cost basis from an in-house development, the cost would be much higher. So your decision of should we implement this feature would be drastically different based on these two different cost measures. Again, we go back and, should we do this at all? It all comes to thinking about the long-term maintenance cost and the risk that comes with integrating that particular service and how it affects for example, your SLA, which is a pretty visible metric, but it's not always the availability. Sometimes, a service that you incorporate, it affects your performance as well. So you have to think, the long-term aspects of all of these metrics when it comes to incorporating a feature And then is it worth on the long run? And sometimes, if, again, this is all about intentionality, by the way. If you're intentional, another option might be, hey, I just want to integrate this turnkey solution, and I understand that it has a long-term impact, but my goal is just to test out the waters. I just want to see if my customers are going to use this feature. If they do, maybe my next step is to say, okay, for now, I'm keeping the third-party service, but next step, I'm going to reassess, reevaluate, and think if I should do this in-house and get rid of the third-party service. So that's another discussion.
Yeah, so basically closer to a discussion of product growth versus scope creep in terms of features.
Yep, kind of, correct.
Okay. Great. So you will be giving your talk at ProductCamp Netherlands, titled Navigating the AI Implementation Spectrum. Quite a buzzword. Could you give us a sneak peek into what's it going to be about?
One of the issues that I actively see recently, especially with the GPT stuff that we have a tool that is very capable, very strong. So I kind of give this example of, we have a huge hammer that we can literally hit anything and it's going to crash everything. But then do you really want to use a huge hammer to essentially, crash a little mosquito? Does that make sense? It might. But again, it goes back to the intentionality and to intentionally decide, hey, do I want to use this huge hammer? And especially if you think that, nowadays it's really a hype, everyone wants to do, it wants to implement GPT, whatever problem that we see, our gut reaction is, hey, I know I can solve it with GPT. But then we have to take a step back because there might be a smaller hammer that might cost less, that can still solve our problems. And we shouldn't just, all of those tools shouldn't be overshadowed by the big guy just because it is big. And it is easy sometimes to implement it as well and to solve the problem instead of customizing something else that is much smaller scope in terms of, AI, the AI model. But sometimes you just, get overshadowed because it's the hype, it's trendy, it's the easy solution. Right? So my session will be about taking a look at the full, and by full, I mean as much as we can cover, obviously, but in a wider spectrum, essentially, of AI tools that we have and how they do match into different, use cases and workloads, and how should we decide which tool to use when? What are the advantages? What are the disadvantages? How much can we customize? Essentially, I could compare it to, for example, the most primitive example to this would be we have Java, C#, and then we have C. So most probably you're not going to build a website with C. But that doesn't make C useless. And there are things that you should do with C instead of trying to do it with Java, right? So those are high-level programming languages, low-level programming languages, and they all have their space in the spectrum of tools that we have. So when you look at the AI as well, we have that spectrum. We have, the full-blown machine learning. We have still AutoML. We have smaller models, larger models. How can we look at that full spectrum and keep that always in mind so that we can select the proper tool for the proper job? So that's what I'm going to talk about in my session.
So we were talking about the implications of GPT and the way it sort of like almost pushes a lot of people to use it and implement it. Obviously quite a charged topic here. I do know that Microsoft is quite committed to sustainability projects and issues. Would you say does Azure itself as a framework do to support sort of sustainability projects?
Yeah. So my role at Microsoft involves helping customer to essentially get most out of Azure, right? That means creating the maximum value for, customers' businesses. Meanwhile, cost optimizing in an efficient way. Again, in an efficient way, that's critical. I just want to emphasize that because we don't want to cost optimize just for the sake of cost optimization, because there's an overhead that comes with it as well. So we want to cost optimize where it makes sense. We don't only, by the way, optimize for cost, we optimize for performance and reducing the overall, impact on the environment as well. So how do you do that? On the DC side, there is already, on the data center side, there's already huge investments in renewable energy that Microsoft is already doing to power workloads. The goal, if I'm not mistaken, the goal was to get to 100% renewable energy by 2025. And the current numbers are kind of getting, on track as far as I know. And one of the things that we do was there's an emission impact dashboard that you can actually go out there and download and then connect it with your Azure subscription and the billing model. So you can download it for free and you can start analyzing your emissions. Some organizations use this to be able to report their emissions to the government. So you can go at, again, this is accessible to everyone. Whoever has an Azure subscription, they can go and download the dashboard and start looking at the numbers. And what they're going to see is that those numbers are much lower compared to an on-prem infrastructure. And it all comes to the scale of the infrastructure as well, and the investment that you can do at that scale to optimize the energy that you're using, right? So that's how the public cloud essentially, it's not only Azure. I wouldn't say, I'm sure the competition is doing their fair share because it's not just our goal. It should be something that we all work together to lower the emissions as much as we can. And cloud, I believe it helps instead of you running a server in your in your building.
Thanks for that. Speaking about the industry, you do have over 2 decades of experience as an engineering leader and solution architecture. Would you share some key insights with us? What shaped your career journey? What brought you to the place that you are in now?
I am all into hands-on discovery. My career has been shaped through it as well. I don't believe, when you look at back in your life, it's kind of easy to connect the dots and, craft a story around that. But I don't think that's how life works. If you look at the future, whenever you try to connect those dots, there's so many unknowns that it's impossible. But when you look at back, you might be able to storyfy that, like you guessed what's going to happen because you already see the dots connected in your past. But I would say, overall, my tendency was to follow my interests. So that's why, I have started, development at the age of 12. I mean, I have even pictures at the age of 3 in front of a computer, which is like, nowadays it's those are common photos, but back in my days, it wasn't that common. So there was always an interest in computers and electronics overall and in math. So I believe I simply liked to create. And, if you look at it, a computer and programming is, I can't think of an easier way that you can make something and people use it. Today, with the internet and the mobile devices that we have, it's much crazier. We couldn't imagine such a thing, 20 years ago. You were essentially sitting down, writing a piece of code, building an app, and next day it's being distributed to millions of devices. The potential is huge. And the feedback loop is so small, and that's the fun part to me. Whenever you are doing something, being able to see people's reaction and see that it's helpful to them, that was directed my whole career, I would say.
Yeah, I can't agree enough about the hands-on approach to learning and the importance of seeing the short feedback cycle to drive you to become better and better. So one of your key areas of expertise is engineering culture. Could you elaborate, give me a rundown of what you understand under engineering culture and why is it important to foster such a culture in your teams and your companies?
Yeah, I see that a huge potential growth area for a lot of organizations because we tend to think of culture and technology in silos. That's actually a clear problem that we did kind of see with when the whole industry started getting crazy with DevOps. But it looks like we didn't learn our lessons. When it comes to the technology maturity of an organization and the organizational maturity, the cultural maturity of an organization, you shouldn't think of these things separate. The moment you start thinking of these things separate means you either invest too I'm not going to say too much, but let's say you invest not proportionally, essentially. You invest more in your people, but not the technology, so that you have a crippled implementation in terms of the organizational, delivery. So then the other way around is something that we see more, right? You invest crazy into technology because it's relatively easier, and that's something that we know, right? You invest a lot into technology, but that you do not invest in your people, and there's a misalignment into it. It's critical to align the both, and it's not easy. It's much easier to do in small organizations, obviously, especially in startups, but I still do see a lot of space for improvement on that. So when it comes to the engineering culture that you're referring to me, this is about, it's about this alignment. The engineering processes and the culture that we have in the organization have to be aligned. I can give you, tons of examples, having, automated processes, but not being able to deliver the tool that is designed to flow fluidly through the automation of the delivery. So let's say, just to give some concrete examples, you have a DevOps pipeline that is able to deliver every second, but that is connected to a team that is interdependent, that is not able to deliver because they depend on each other, because you have silos in the organization in terms of skills in your people or teams. So having that pipeline that can deliver, 10 times a minute doesn't make sense, because your people aren't going to be able to deliver functional output 10 times a minute. So you have to have that alignment. You have to make sure that your automation is aligned with your people in terms of the production, systems that you have in place. So that's my focus area when it comes to, and we have a lot of discussions with customers about this. Another way this services out, and I see this a lot as well, as, microservices versus organizational skilling and organizational structure, essentially. I do see a lot of organizations that have, for example, let's say you have 200 microservices, but 20 people trying to deliver it, or the other way around, right? So microservices is a design, is an architecture choice, but did we make that choice based on the maturity and the organizational structure that we had? Otherwise, there is misalignment. I kind of try to fix that problem by talking to people and having those discussions and try to understand their perspective as well, so that we can find a middle ground between those two different worlds. They're not supposed to be two different worlds. That's the primary issue, actually.
Yeah, speaking about two different worlds, I have in my notes here a question about work-life balance. I kind of find this a little bit triggering to myself, considering work not a part of your life has always seemed a little bit unhealthy to me, but still you do focus on coaching and wellness. Would you say, what advice could you give to other people to go down this more wholesome and holistic approach?
Yeah, work-life balance. So my perspective at it is, if you consider these things as two separate things, you have to balance. But are these things two separate things? That's the question. And the answer depends to the person, to be honest. For some of us, we are so ingrained with the work that we do. Let me give you an example. You are going to see, so I have those different profiles in my teams, actually. As a developer, you might be still coding during your weekend. You might be still coding outside of the work hours. You don't necessarily have to do the actual work of your employer, but you go out there and do something. So essentially, development is your hobby. So in that case, I don't think you have to enforce this concept that, hey, no, there needs to be a balance. So I shouldn't be coding, during my off work times. I should be doing something else. It depends what you are feeling out of it. Do you feel some kind of an imbalance? That's the first question. Imbalance, for example, that's the first question maybe one should ask themselves. And this actually touches into the engineering culture that we talked about and team management, because you are going to have different people coming with different perspectives and backgrounds, right? Like I've said, you might have a developer who thinks like, hey, this is my hobby as well, and I love doing it, and I'm going to keep doing it. It doesn't, I'm happy with it. But then you're going to have another developer who prefers, to shut the laptop and do something else during the weekend. It just means that they have a different hobby, and that's perfectly fine. I don't think just because you're a developer and you end up doing that to get paid, development cannot be your hobby anymore. I know I'm not answering necessarily the question, because I don't believe there's a straight answer to that question, and that depends to the person and how the person feels about these things. But I personally think, like, if you feel like there is something that has to be balanced, one might argue that there is definitely an imbalance in there. You should focus on improving that feeling by focusing on where you feel positive. That's a critical thing to do, by the way, when we focus on problems and fixing problems, which is an inclination that we have as developers, because that's how essentially we make our money, right? We find a problem and we fix it as an engineer, right? So, but when it comes to happiness, another option is to find what makes you happy and increase the amount of it. So whenever you feel like there's an imbalance, find the thing that makes you happy and try to increase the amount of it. Most probably that will get rid of that imbalance feeling.
That's a nice tip to start off. Could you perhaps share any more sort of your development wisdom with people who are just starting out in the tech fields? What would you say are the key aspects of their work and their life to focus on to bring them up to the next level in this tech field?
Find a problem. It's kind of easy to say. I'm not sure if it's easy, but I might say, like, hey, go do this program, go to study this. This is trending nowadays. Go work on this and that. But then again, things are going too fast, and the pace of change is increasing. For example, when it comes to career planning, in the past, we were talking about 10 years plans, 5-year plans. Nowadays, we're talking about 2-year plans. So that iteration is going smaller and smaller because the unknowns are increasing and we're not able to see the future, or the extent that we see and we can estimate with a particular confidence level is getting shorter and shorter. What can you do in that case? What value you can create? One option is to try to estimate what's going to generate value and invest in learning it by actually doing the learning, and at the end being the person who knows. But being the person who knows, is that what you want to be versus being the person who can do? I know that kind of being the person who can do sounds more sexier, but let me explain. If you find a problem and you learn to fix that problem, right? Your goal is to solve that problem, and that gives you direction. And on that direction, you start learning the tools that are useful to go to that direction, right? To solve that problem, you figure out, hey, I need to learn this, I need to learn this, and I need to learn that. And you learn as much as it's useful to solve that particular problem. That's kind of the drawback of this strategy. You never learn the whole scope of one thing because you only learn that is functional to solve that problem. But the advantage of this is that you are getting the hands-on experience, which you cannot replace by anything else. The other strategy is, hey, I don't have a necessary problem to fix right now. I just want to know this, right? Know X. So in that case, you might be able to accumulate a wider knowledge base in terms of the concept X, for example. But first off, you're lacking the hands-on experience, which means you don't know for sure what you have learned is useful. And then the other disadvantage is, usually what I say is, it's harder to motivate yourself to be the person who knows versus to motivate yourself to solve a problem, because when you solve a problem, most probably you are delivering value to someone and you are getting feedback. But when you learn something and you are the person who knows something, you're just the person who knows something. I mean, it's a beautiful thing, but it doesn't spur up that high levels of motivation that you get from delivering the value and getting the feedback. Just being the person who knows something, it's a harder goal to chase. So advantages and disadvantages of both. I believe, by the way, again, I'm going to give a little bit of a blurry answer here. I believe we need to balance the two. I believe we have to go with a hybrid approach and say, hey, there are some problems that I want to fix. I found a problem and I'm going to work towards it. But on the other hand, I just want to challenge my mind and learn something just to know it because it's interesting. And if you can combine the two, then that's how you lead to interesting innovations, actually. Working towards a problem and learning on the way assumes that the problem that you are trying to fix is the right problem, and that's going to lead to the right learning. We don't know that. So I'm kind of trying to compensate that with simply, combining that approach with something else, which is, hey, I just got to learn this topic without any specific, problems in mind, and then I'm going to see if it matches to anything. I'm just playing the random game a little bit and mixing the two approaches together.
And to summarize, then this on a high note, looking forward into the future, what current trends in tech are you most excited about? What makes you happy to be living in this time?
I am very excited about getting the cloud to where it is supposed to be, which means serverless. When we all started with this, 10 or 15 years ago with this whole cloud thing, the idea was that we will have this platform, we put the code and it just works. We didn't end up there. Today, when we put our code into the cloud, most of the time what you're going to see is that even, a lot of the platform as a service level services ask you to decide, hey, they ask you how many cores are you going to provision. So if a service is asking me what I'm going to provision, that means it's asking me to estimate what type of load I'm going to generate, which is, to me, that wasn't why we wanted cloud. I mean, cloud has multiple benefits, obviously, but the dream was that you are going to be totally encapsulate away the hardware world from the software world. What does it mean? When I'm writing a code, I don't want to think about your physical life limitations that you cannot put more than 500 cores on a single machine. Because we know as engineers that, writing a code that works on a single machine is, an architecture, building an architecture like that is different than a distributed architecture, right? If your code is supposed to run on two machines, then you have additional problems. So, but then again, it's a problem due to your physical life limitations, not my code. I mean, I kind of give the example of, when I'm writing an application today, I'm not interested if the, computer has a hard drive connected through ID or SATA or whatever. The operating system encapsulates that away for me and gives me a logical file system, and that's what I work against, right? So I don't care about, what kind of hardware connection the hard drive had. So why would I care about your physical life limitations in terms of how many cores can exist on a single, unit? That's the problem that I expect cloud to solve. And today, serverless is the closest we got to it. And with the AI models, with the introduction of AI, it's going to be much more critical to be able to do that. Thankfully, a lot of the AI services, at least a lot of them today, are not stateful at some level, so it's not being a huge problem. But then again, we have to solve that problem of real life limitations being imposed on applications that we build. So long story short, serverless is my recent excitement, the thing that I focus a lot recently: serverless compute, serverless databases, and all that.
Daron, thank you so much for spending the last 40 minutes with us. It was an enjoyable talk. I am very much looking forward to seeing you on ProductCamp in September.
Cool, thank you. Okay, this was lovely.
Okay, thank you. Bye-bye.